Chapter 3: Motherboards. The motherboard is the single largest component of your computer. It is the printed circuit board that all the major components mount to or connect to. Understanding the motherboard is therefore very important. As a technician, we need to understand the motherboard because it serves as the communication center for all the input and output devices. All the major devices such as a mouse, keyboard, video display, network, USB devices, sound devices, and other devices connect to the motherboard. The motherboard has connections for the switches on the case of a computer and the connections for the fans that cool the components of the computer. It provides a way for expanding and customizing the PC through the use of expansion cards. For example, you can add additional video or sound capability by plugging in new cards. The motherboard is not usually something that we repair. It's considered a field replaceable unit because it cannot be repaired on site without the use of very specialized tools. If there is an electronic failure on a motherboard, it is usually replaced. Fortunately, most problems with motherboards do not involve the electronics, but rather the configuration of the motherboard. In fact, many motherboards are thrown away because they are simply not configured properly, or parts that are incompatible are installed on the expansion bus, or perhaps they don't have a sufficiently capable power supply. So it's important to understand about the motherboard and how it functions, to be able to identify whether the problem is hardware or software. Now, since the motherboard is the main communication hub, we need to understand a little bit about how the motherboard is constructed and how its parts talk to each other, the communication system, and the architecture of the motherboard. And if we do understand that, it will be very helpful to troubleshoot the motherboard if something goes wrong. It also is helpful to understand the architecture when we go about upgrading a PC. This presentation has a number of objectives. We'd like to identify the major parts of a motherboard and the common motherboard styles or form factors. We'd like to explain the motherboard bus architectures and identify expansion slots and how they're used and what their architectures are. We'd like to identify important system resources and explain what they're used for. We'd like to identify and explain interrupts or IRQs and why they're important and what they do and when and what can go wrong with them. What is meant by a chipset and what is its role in a motherboard? What is the purpose of the CMOS setup program? And what is the procedure for upgrading a BIOS on a motherboard? I've divided this presentation into 4 areas. First part is motherboard construction and architecture. Second is expansion slots and cards. The third is the system resources. And the fourth is troubleshooting the motherboard. First, motherboard construction and architecture. If you look at the back of a motherboard, the first thing you'll notice is a multitude of copper wires running around on the surface of the motherboard. The motherboard is a piece of fiberglass with wires on the surface and embedded in it. The wires connect the many components of the motherboard, and the wiring is very complex with multiple layers on both sides of the motherboard as well as layers inside the motherboard. And this is the wires that carry both signals and electric power to all the different parts of the motherboard. On the top of the motherboard, the major components are mounted. The most obvious component that one sees is the large fan that is usually near the processor or CPU. Underneath the fan will be a heatsink, and then underneath the heatsink will be the CPU. The CPU is the brain of your computer. It is the part that executes instructions. We will look at the CPU in greater detail in our next chapter. Other major components we'll find on a motherboard include additional large integrated circuit chips. For example, this is a very important chip. This is called the North Bridge, and it is always located close to the CPU and works closely with the CPU in communicating between the CPU and the other parts of the motherboard. Everything that the CPU does communicates through the North Bridge chip. In addition to North Bridge chip, there's another chip called the South Bridge chip, which is also involved with interfacing to input and output devices on the motherboard. Another large component that you'll notice on a motherboard are the expansion slots. Different motherboards will have different numbers of expansion slots and different types of expansion slots. Some motherboards may not have any at all. The reason for the expansion slots is to add new capabilities to the motherboard. For example, video capability. If you want to add greater video, you can add by plugging into expansion slots. Another thing you'll notice on a motherboard are the memory module sockets. You can add, in most motherboards, you can add additional memory. There's an area of the motherboard that provides connections to the outside world. The input-output connections to the motherboard are located in a particular configuration that is standardized. Another thing you may notice is various other components scattered around the motherboard. A number of different smaller integrated circuit chips. You will notice some little can-shaped objects called capacitors that are used to filter the electric power, and other various components, resistors and individual transistors mounted and regulators mounted on different places, and then connectors for power and connectors for the hard drive and CD drive, perhaps a floppy drive, and of course power to the motherboard. Now, one of the things that the motherboard does is it provides communication to the different parts of a computer. And the communication signals travel through groups of wires called bus systems. Buses are just a number of wires that serve a given purpose. One set of wires or bus is called the local bus, or often referred to as the front side bus. The local bus's job is to communicate between the CPU and the North Bridge chip, the other large integrated circuit, which is located very close to the CPU. And the front side or local bus carries the fastest data on the motherboard, except inside the CPU itself. It also may connect to an external cache memory, a very high-speed memory that the CPU uses for program execution and runs at a very high speed. So the local bus speed affects the performance of the computer very directly, because the CPU is restricted by how fast the data can go in and out of the CPU. Another bus you'll find on the motherboard is the I/O bus, or input-output bus. The I/O bus connects between the North Bridge and the high-speed expansion slots. This is the bus that allows control of external devices outside the CPU and the expansion cards that would fit in the CPU on the motherboard. And it also connects between the North Bridge and the South Bridge chip, and input-output connections on the motherboard. The memory bus carries data between the memory modules and the North Bridge. It is the second fastest bus on the motherboard. It has to be quick because it's transferring data to and from the RAM memory in the memory sockets. And so the north bridge is a go-between between the CPU and the memory. And then we should mention the internal bus. The internal bus refers to wiring that carries signals inside the CPU itself. These are microscopic wires. We can't see them unless you open the lid on the CPU and looked at it with a microscope. But these are the very fastest of all signals. These signals operate in the very highest frequency ranges, in the billions of cycles per second. And so these are signals that travel across the different components within the integrated circuit. If you look at the inside of a picture of an integrated circuit, you can see patterns that represent the various parts of the CPU, including, for example, in this picture we're looking at a quad-core processor. You can actually see the 4 separate individual processors. You can see the internal memory, called the internal cache memory, that the CPU uses in these large dark areas here. So each core or each separate processor has its own group of memory. It has 2 caches, and the other components of the CPU, the logic and so forth, are in this large block here, and each of the CPUs. And so those include the major bus systems. In addition to that, there are a number of other buses. One is called the power buses, which means wires that carry electricity to the various parts. So these are usually larger wires that carry electric current to power things across the bus. So all of the different components that require electricity, of course, all the integrated circuits, the CPU itself, and the north and south bridge all require power, as do all the other components. Now, wires that carry data often are referred to as data buses. A data bus is a group of wires, and they're grouped in groups usually of 8, 16, 32, or 64 bits at a time. The original IBM PC's data bus between the CPU and the memory was originally 8 bits. Later CPUs went to 16, 32, and then 64 bits. The latest computers could handle up to 64 bits at a time, which means 8 bytes at a time can be processed. A control bus is a group of wires that are used as controls for the flow of data. For example, whether the data is going to be read or written to the memory, or which way the data is flowing, are all controlled by control bus wires. They don't carry information themselves other than to control the flow of information. And then the address bus would be a bus that carries address information that is used to select where data is going, to either to a place in memory, a memory location, which is going to be written to or read from, or a device, an external I/O device, which is going to be written to or read from. And so the address bus serves a very useful function of selecting locations. So the data bus and the address bus often work together.